All right, so these are the notes on the Pearson correlation coefficient. And make sure this is the right set of notes. Okay, I need to change the title here. But anyways, the topic here is regression and what we call Pearson correlation coefficient. Today you're going to be doing what's called linear regression. And regression is simply finding and I'm going to say curve. Sometimes it's a line. Today is all about lines. Finding a curve of best fit for data. That's all it is. And we used to do this by hand back in the day. Thankfully, that predates even me, as old as I am. We have what's called a Pearson correlation coefficient. There's a lot of words here. But this indicates how well a line of best fit or curve of best fit correlates with data. It has a value between -1 and 1. Negative values imply a negative correlation, and positive values imply a positive correlation. Again, pause the video, write down all this stuff. It's important. Moving forward, stuff about the correlation coefficient. All right, and there's some more stuff in here that's not actually mentioned. It is allowed to be negative. R, the correlation coefficient, is something stuck between but not including -1 and 1. And we've got things up here like R equals 1 is a perfect positive. R equals -1 is a perfect negative correlation. Now, if you're actually listening to the audio here, a negative correlation would be something like the amount of time spent on TikTok and my grade in Mr. Milbrath's Algebra 2 class. A positive correlation would be the amount of time I spend actually trying to learn the content and my grade in Mr. Milbrath's class. All right, so again, this stuff's important. It talks about where we're strong, where we're positive and stuff like that, where we're weak. So pay attention to those little things. All right, Bella recorded data and used her graphing calculator to find the equation of line best fit. She then used the correlation coefficient to determine the strength of the linear fit, which correlation represents the strongest linear relationship. And it's not about being positive. Now, if there was a choice 5 here that said -0.93, it would be the best. All right, it's about being the closest to either 1 or -1. That's what it's about. The closer you are to those two numbers, the stronger you are. Now, there is no choice 5, so this is the best choice. Because this one's really close to -1, but it's not as close as 9/10 is to +1. It's supposed to be closest, isn't it? Put that little T there. All right, moving forward. Analysis of data from a statistical study shows a linear relationship in the data with a correlation coefficient of -0.524. Scan back here. You'll see that that is in the range of being moderate. That is a moderate thing. And you know, I'm a math teacher, so I'm saying memorize this right now because that's how it works. It's funny how we're like that. But that is not strong. That is not strong. So anything with a strong is gone. It's got to be one of these moderates that I'm looking at. And it is negative. Do you see the negative symbol? Because you can read at a 3rd grade level. Choice 4. The results of a linear regression are shown below. Y equals ax plus b, and they give you the terms here. Which phrase best describes the relationship between x and y? I'm going to focus on the Pearson correlation coefficient because it tells me the relationship. First off, it is negative, so anything with a positive is struck through. Not going to happen. You know, on standardized tests, there's usually 2 that are just completely wrong. So it's really a choice between 1 and 3. That is a strong negative correlation because that is really close to -1. Moving forward again, what is the correlation coefficient of the linear fit of the data shown below to the nearest 100th? You're going to have to use your calculator to do this. First off, let's go ahead and make a small table. So this will make it quicker. X is 2 and Y is 8. X is, sorry, I also missed the first one. X is 1 when Y is 8. X is 3 when Y is 5. X is 4 when Y is 3. X is 5 when Y is 4. X is 6 when Y is 1, and X is 8 when Y is also 1. I need this, and you may or may not remember this, but the general list is the X's go into, or replace the X's into list 1, replace the Y's into list 2, and you should probably be taking notes on this. And then we do stat, calc, and the choice here was lin reg, and it was AX plus B. It's choice 4, by the way. But there's something else we'll have to do first. But anyways, let's go through here. Let's get our crap in here. Stat, edit. If you've got anything in your list, you just highlight the list and hit clear. Don't hit the delete key. If you do hit the delete key, here's what you do. Like, oops, just hit the delete key. You go to stat, you go to 5, you press enter, you press enter, and it'll put that list right back. The odds if you remember that are slim to none, but maybe you'll remember it. All right, so X is into list 1. Your Y's go into list 2. The only way you can mess these things up is really just to have typos. Now, I'm going to go through like I'm suggesting here, stat, calc, 4, linear regression, and as a refresher, you scroll down to calculate. All this does is give, well, you weren't supposed to see that. I forgot to turn something on. There's an R value here, but you only get that R value if you do something first. And I'm going to make sure that as we do this little unit that I reset calculators every single period, so that hopefully all of you, but probably 2 or 3 of you will actually know how to do this. But to turn on R, you hit second 0. All right? Now, I'll walk you through this in just a second. You scroll down to diagnostics on, and then you press enter twice. So I've already done that on this calculator. Second 0, that's catalog. See where it says catalog? And you can scroll down. You can actually get there quicker by hitting the D key, if you can find it. It doesn't take that long, though, to scroll. There she is. Press enter. Press enter. And that gives you that R value. All right, that's why that R value is there. All right, so they asked me to find the R value. It's right there. Notice it's negative, so choice 3. Easy peasy, lemon squeezy. The points in the scatter plot below represent the ages of automobiles and their values. Based on this scatter plot, it would be reasonable to conclude. I don't like the way the author wrote this particular question because choice 1 seems very, very valid. But, and it does, because this relationship is pretty darn strong. It's almost a good line. Had I wrote this question, I would have said there is a strong negative correlation. That would have been the answer choice here. But they do have a correlation that's greater than 1/2. It's actually negative, but that doesn't matter. It's actually a pretty strong relationship. The way the author wrote this question is kind of odd, but the best choice is 4. A case could be made for 1, but the best choice is 4. At Mountain Lakes High School, the mathematics and physics scores of 9 students were compared as shown in the table below. State the correlation coefficient to the nearest hundredth for the line of best fit. I'm going to go out with 4 decimal places. Explain what the correlation coefficient means with regards to the context of the situation. So it's stat, edit. We'll see if you write this down or not. I don't know. Some of y'all don't take the best notes. But the way I've always taught this and the way I always will which is unless somebody is trying to just be mean to you, the first column is going to be X, and the first row is going to be X, and the second column is going to be Y. And just pay attention to text, because sometimes people do try to throw you off. Because the first row would be your independent data, and the second row would be your dependent data. I've lost my little stylus here. That stinks. This is X. This is Y. All right. So anyways, back to my TI-84. Maybe my little stylus will show up. Throw all my X's into list 1. Be careful you don't make any typos. And throw all your Y's into list 2. And then you go through the old run-of-the-mill stuff here. Stat, calc, choice 4 is linear regression. Scroll down to C-A-L-C-U-L-A-T-E, calculate. And you will have your regression equation. And here she is. So explain what this means in words. So let's look at the correlation coefficient. The correlation coefficient was really strong. It was really close to 1. So I could say that there is a strong positive correlation between a student's math grade and their physics grade. Because in order to be good at physics, the truth is you have to be good at math, because physics is math. That's all physics is. Physics is applied mathematics. All right, so if a student has a physics grade of 98, what does your line of best fit suggest their math grade was? So they have a physics grade of 98. Pay attention, this is Y. All right? That's Y. That goes right there. 98 equals 0.0809. I just went blank for a second. I introduced way too many zeros in that thing. 0.8099x plus 15.1854. We're just going to subtract that 15. Why am I pulling up a calculator for this? I have no idea. I'd been done by now if I hadn't pulled up a calculator. And I get 82.8146. And that's going to equal this 8,099 10,000ths of x. And we're just going to divide that out. I'm not sure if I said that right. And that's going to give us their grade. There we go. I expect this kid to have 102. And they probably want me to round it up to 103, but it's 102. Strong kid. All right, moving on to 14. Which scatter diagram shows the strongest positive correlation? Well, this one would be negative because it's kind of an idea of slope. So it's not this one. Here, and we don't have much practice with this yet, but this would be a weak line of best fit. The R value is probably around 0.2. This is even worse. Like there's The R value is, I guarantee you, it's 0. It's this one. We have a nice, good, best fitting line. And we're going to have a strong R value. And it will be positive because it's uphill. So it's choice 1. And I'll try to explain some of that here on this slide. I'm going to spend a little more time on this one than you care to, but I'm going to do it anyways. All right, use your regression equation to estimate how many milligrams of sodium a hot dog, oh, sorry, there's a whole bunch of stuff. First off, come up with it. So off to stat, scroll to edit, start putting stuff in. This is going to be X, this is going to be Y. All right. And I'll be darned, it's after 3 o'clock and the sun came out and I'm still here. I've been here all day and I haven't seen any sunshine. And now that the sun's out, I'm still here. That kind of aggravates me a little bit. I should be on my merry way home. But I didn't want to come in tomorrow morning and have to do this. I have other things I have to do, like prepare your next lesson after this one. Because I decided I would reinvent the way I teach Algebra 2. Stupid me. So anyways, ranting aside, there's the stuff. Stat, calc, 4, linear regression, calculate. I'm actually going to do something different here too, by the way. I'm going to go down to store regression equation, and we'll do this another day. The next lesson will have a lot more of this. Go to vars, y variables, function, y1. That is going to take this equation and put it in y1, all right? So it's already in the calculator. And I'll show you what that looks like in just a second. Anyways, there's that. Now, I put that in a calculator. It takes the entire thing and puts it in y1. That's what it does. That's from earlier. Let's clear that out. I'm also going to turn on what's called stat plots. So second y equals, I've got them on this one already. You press enter, turn on. Then I'm going to do what's called a zoom 9, zoom statistics. And there is the scatter plot, and you can see my line going through it. And it doesn't look like a bad line, but I do know there's something that fits it better because it's got a little bit of a parabolic curve to it. But anyways, let's go back to this question. They told me to do line of best fit, so I did line of best fit. And I got an R value that's pretty stinking high. It's 0.9422. So there's part A. Part B is explain what the correlation coefficient suggests in the context of this problem. It is suggesting that as calories go up, it is likely, very likely, because it's a strong correlation, sodium goes up. And you can look at the table and figure that out for yourself, kids. They do correlate, apparently. Use your regression equation to estimate how many milligrams of sodium a hot dog with 250 calories has. The old school way of doing this is realizing that calories are X. So Y would be 4.5875 times 250. Take away 346.6019. It'd be cool if I've done that at some point in time. I'm just calculating. The second time I've done these notes, I modified them. There it is. It's 800.2731. It's about 800. About 800 calories. So anyways, I wanted to spend some more time on this. And I know you don't want to watch it, but whatever. Let me go back to my window here. The calculator has a lot of cool features, like you can actually plug a number into a graph if you have it. So second trace value, X was 250, but I'm doing this so you see it's not going to work. I'm going to press enter. It says invalid. The reason it says invalid is because if you look at your window, the window only went out to 195. If I want to plug 250 into this calculator, I probably need like a 260 as an X max and graph. So let's see what happens now. Second trace, value, which is choice 1, 250, and you see that 800 that I just had, it's right there. Now, I mentioned that I felt like there was a better fit for this thing, okay? Because tomorrow, the next lesson is about identifying things that fit best. That's what it's about. I see a parabola. I see half of a parabola, and there might be a case that this is an exponential function as well. But anyway, second quit, I'm going to go to Stat, Calc, down to Quadratic Regression, which is the parabola, and I am going to store the regression equation into Y2. Second, bars, oh, dang it, I do that often. I've always done that. Stat, Calc, I was doing a quadratic regression, which is choice 5. Vars, not second bars, Y variables, function, Y2. And that's going to take this equation once it generates it, and it's going to put it in Y2. If I go to Y equals, I'll see that it put something in Y2. If I hit the graph key, I'll see that quadratic being drawn in red because I have a cool color calculator just like you, at least you do in my classroom. And look how good it fits that data. It fits it a whole heck of a lot better than the line did. Well, I should have made a copy and paste here, so let's go through that process again. That was choice 5, quadratic regression. Let's take a look at the R value. This one says R squared is roughly 0.9579 and some change. So R is the square root of that thing, 0.95795, whatever. So let's see what that is. Sadly, you have to copy it all down. I don't know why they haven't fixed that yet. 0.95795. 17817. And we get that it's about 0.9788. If you make the comparison, it turns out that a quadratic was the best curve for that function. It was. But anyways, we'll do more on that tomorrow. Or the next day, whenever I see you. I'm recording this anticipating a whole bunch of snow next week, so we'll see what next week brings. Enjoy your 3-day weekend at a minimum.